I am so glad you're here for another episode of Mastering Organic Synthesis. In the last video, I asked if you could come up with the synthetic route for this chemical transformation. So if you haven't had a chance, pause the video now and try it independently. And make sure you stick around to the end because I'll give you another problem to solve for our next video. Above is the synthesis of propranolol, which is the specific class of drugs known as beta blockers, which help treat heart disease and even reduce the side effects of things like anxiety. And there are multiple ways to achieve this synthesis, starting with naphthol, getting all the way to propranolol. One of the most common pathways is going to be through the alkylation of this alcohol to give us an ether. And we can do that by deprotonating the alcohol and then adding an alkyl bromide, for example, to do a substitution reaction. So if we add a base, then we can deprotonate that alcohol, making it a good nucleophile to do substitution reactions. So for example, if we have an alkyl bromide, one that has perhaps this alkene on it, then that will give us another functional group that we can later do things to. So the product of that transformation is going to be a new ether where we previously had an alcohol. So once I draw that in, you'll see that now this oxygen contains an alkyl chain where there's also this alkene on it. And then if you notice, if you were to consider this carbon 1 and this carbon 2, what we have here is carbon 1 and carbon 2, but also carbon 3. So notably, we need to add an oxygen at that second carbon position. And a way that we can do that is by first turning this into an epoxide and then doing an epoxide opening reaction. You probably know several conditions to turn alkenes into epoxides, one of which is going to be MCPBA, but you can also use things like RCO3H to make an epoxide where you have an alkene. And importantly, these reaction conditions can tolerate the rest of the molecule. And that's another thing you need to consider when thinking about multi-step synthetic reactions is, can the conditions that you're choosing tolerate all the different functional groups? And then from here, remember we had counted these carbons as 1, 2, and 3. So here we have 1, 2, and 3, which means that we need to introduce nucleophile that will attack at the third carbon position to open this ring and give us an alcohol at the 2 position. And notice that an alkylamine is what is present on the other end at this carbon 3 position. In fact, we can just take that amine, which would be NH2 with this alkyl chain on it, and this would in fact be the reaction that would occur at this carbon position, which is going to attack at the less hindered carbon in order to open up this ring and allow us to get an alcohol. So in fact, that is the last step of this transformation and how you synthesize propranolol, starting with naphthol. To recap, we started with an alcohol and converted it into an ether by introducing a base and an alkyl bromide. From here, we converted the alkene into an epoxide using oxidative conditions, and subsequently opened the epoxide ring to give us our alcohol by introducing a nucleophilic amine. If you enjoy these types of multi-step synthetic practice videos, you can also join the membership down below to get even more practice. In the next video of this series, I'd love to see if you could figure out the multi-step synthetic route to perform this chemical transformation. I'll see you in the next one.